Hello, guys. Long time no talk. Gosh, it's probably been a couple months now since we've had a video update of this manner. I'm going to be talking about a lot of things long term, next week or two, mainly March. Some AO research, Arctic oscillation research I'm doing. So let's just get right through to it. This is a 7-day forecast. This is a new project I've been working on for basically to create a Wisconsin centric forecast, not one particular spot. I will say that this data set is uh, initialized from the Wisconsin Rapids site. But anyways, you're seeing that there on Thursday through Saturday. Well, Thursday's today. So Friday and Saturday, you're running temperatures that are near to, below, probably below average there, but turning towards near, and then shooting above into the positive category, well above average from Sunday through into Wednesday, probably. If you go and take a look at the temperature graph here, you're going to see that this is for Wisconsin Rapids. You're seeing that, yes, there on Saturday at 32 is around average. And then, yes, boom, Sunday through Monday, Tuesday, Wednesday, above average. That's how that breaks out. So I want to talk about the MJO. We always talk about it. And if you don't understand it, I mean, maybe go back and watch some of my other videos where I try to explain a little bit more detail. But as you can see here, we're right now we're in phase 8. It's really right on the edge of the uh, neutral circle, and we're going to be crossing over the neutral circle. So we're probably not going to have too much of a tropical forcing going on here in the next week or two, or I would say probably the next week, because that last observation is from the 24th. So it's looking like by the time we get to the data updated, we'll be near the center. So we're heading towards phase 4. And why I find that interesting is because we're not heading around the circle into 1 or 2 or 3, which tend to be the colder phases, cold and dry phases for Wisconsin. We're heading basically another distinct turn away from that into a 4, so that when we get it to a 4, naturally it will tend to go towards 5, 6, and 7. Doesn't, maybe not always, maybe it'll cross back over the neutral circle and go into 1, 2, or 3 again. But right now, this is the sort of the way it's shaping up and the way it's gone this winter. But yeah, we'll see how it goes. This is the European forecast. The GFS is just slightly different. And, perhaps there's some loop-de-loops that go on there in 4 and that delays this whole process. But yeah, 5, 6, 7 are definitely on the table. And I would actually say that that's more likely than 1, 2, and 3 as we go into March because, yeah, it just seems like, in other words, and in a nutshell, we're favoring the warm wet pattern here. According to the MJL, that's just one part of the puzzle. As you can see that we have phases 5, 6, and 7 as they relate to March. The moisture in 5 is not as great, but it's definitely that signal there across the, I guess, the Midwest region into the Great Lakes. But that becomes more amplified in 6 and 7. As you see there on the left, that's the moisture streaming in. There you see those moisture I guess deviations from the normal there, and then on the right side you have the temperature. Where actually at phase 5 it's colder than average, and I think that that's actually probably a next step. You may have some colder days there in early March, but then it's going to turn probably. Okay, so if you go down this road of 5, 6, 7, it's cold kind of right initially, and then not blowtorch warmth necessarily, but warmer. Phases 6 and 7 definitely. And then with that warmer temperature, you get the stormy pattern. So let's go through let's take a look now at the Arctic oscillation. I'm sorry, my head's in the way. I'm going to remove that for a second. I'm not going to remove my head. You know what I mean. Okay. Now this is kind of an interesting graphic here. I don't have my drawing tools. But right in here, this is where it's positive. And it's been pretty positive right straight through January. I mean, we really started to turn in November. Not November. Oh, yeah, I would say that's November. We made a turn from a negative negative AO to a positive AO. And that regime has just been escalating upwards since December 1st. So you're seeing that here's the first spike in here. The next spike here, January 1 through 16. A little bit of a lull and then back up again. And when we hit these spikes, the spike here in early February was like one of the strongest spikes on record. And then we actually went up that later there, a few days later in February. So again, we're still here in February. It's the 27th. And you're seeing right now, looks like we're heading down into one of these dips again. But the dips themselves are not negative. They're barely even neutral. they're positive, definitely positive overall. So that's a regime. This regime is a positive, strongly positive regime, bouncing back and forth within the positive. Now, typically, if we go back to November, December, now November again looks like it's mainly negative. We'll talk more about that. But you're seeing that, yeah, I mean, this is sort of the normal natural variation, it seems, or maybe the default variation. We have modes that are positive regime and negative regime, but yeah, I mean, this is sort of like the in between, right? This dotted line. So again, my point here is that we've been on the positive end for a pretty long time. This indicates a strong polar vortex that it's centered over the North Pole area region, generally speaking, as opposed to kind of coming south and mixing and causing chaos that way. Basically, you just got the Arctic Oscillation spinning and gathering strength and energy. As we head into spring, it typically tends to weaken and, I guess, fall apart and unravel. So we'll talk about that. If I can get my mouse in the correct spot, here's the Arctic Oscillation monthly average data going back to 1988. I have this organized by winter year, which starts on the 7th. So that winter year belongs to the year that the January is in. So basically here at the very top, this 0.3 on the 1 corresponds to 1988, whereas anything left of that would be 1987. Okay, the reason we do this is because the Arctic, Wisconsin, the way things work up here tends to work better if you organize it centered on the coldest months of the year, or basically December to January, just generally speaking, because if you center it by, if you do it just from the 1st of January to the end of December, you're getting two different winters, and sometimes the things evolve differently, and they're not really necessarily correlated in any way. So that's just an interesting thing. Again, so what I'm pointing out is I just want to make that clear that this is a winter year, not a calendar year. And so you're seeing this 2020 here in the bottom. I think you'd be able to get the point at this point. So when we look at the January 1st, now the February data is not in yet. It's delayed. But the January data showed a 2.3 variation, positive Arctic oscillation. Now if we go back to December and then November, if you look at November, you had a negative 1.2 there on that value. So that's kind of an interesting flux, right? We started negative and then went positive, and we've been pretty positive now. So February is going to be greater than the 2.3. It's probably going to be up near 3. Now, when we get up into that territory, it's hard to find many analogs for that. So we have to go all the way back to 1988 and 1990. So you might hear comparisons to those years. And in 1990, for one, you did have that negative anomaly during the early part of the winter. That one was in December. Again, ours was more centered on November, but that year was in December. And then as time went on, you got to February, and that's when it peaked, was sort of in that February timeframe. And then March was positive, and April was positive. 1989 is also very similar. It's a similar magnitude positive AO, and you see that kind of carried over right through spring. I'll talk about the rest of spring and what the AO means for that another time. I haven't done that research yet. I've pretty much focused in on February and March, trying to figure out where we're heading, I guess, now in the short term. When we look at the March anomalies based on the top 10 positive AL values for February, you're finding these relationships or these trends. So the left is temperature. You're seeing that temperature is below average across northern United States, above average in the eastern side of the United States, with a temperature gradient somewhere across Chicago, Milwaukee, northern Indiana, Illinois. When you look at, this is for March again. And then when you look at the precipitation tendencies for those above positive, strongly positive AO years in February, what that leads to in March tends to be a positive, above average precipitation trend across the eastern United States, including portions of Wisconsin. Now, it may not be the entire state, but looks like for the most part, it kind of applies to everybody there. So when you go, as members go in to look at my monthly forecast on our website, wisconsinws.com, you're going to see that trend. That's where it comes from. Okay. Again, there's many other things you could look at to say what's going to happen. There's so many. It's such a complex system. But I think right now we're seeing that the biggest thing that sticks out is the Arctic oscillation. And so that's what we're kind of basing this off of now. We'll see how that goes. Okay, this is some of the other oscillations we look at. PNA is going into negative category, so that tends to create a negative, a trough in the west, which produces a jet stream through the Great Lakes region, generally speaking. So that's a stormy pattern for Wisconsin there on the PNA. The EPO is sort of positive. It's not really indicating any massive uh, unleashing of cold air. The NAO has been positive, and it's kind of been just marked. Like it's and I'm still trying to figure out what that impact is for Wisconsin, the NAO, but we'll get to that another time. Now here's just another view of that. Here's the ensemble AO forecasting, and I just showed you that, so you should be familiar with it. Now, if you look at the PNA, you're seeing that, yes, we do have that negative coming up, but it looks like any negative in the recent time, so since November, mid-November, it's not really been ever negative. It's sort of been right there at the neutral. You had the January, that January 14th timeframe where you see that dip down, but it's not like a massive dip, and you don't see any massive positives either. So it's right there at the neutral. So what I'm thinking is the Arctic oscillation is really driving everything right now. Because if the PNA, and if it makes sense, right? So if you have the AO kind of going into the negative phase, it would induce more amplification in the pattern. And so that makes sense. It kind of checks out here, the PNA being right there at neutral. And the NAO is kind of really consistently positive, weak positive there. Okay, now that we got that out of the way, there's going to be a little bit of a data analysis section here. And hopefully that won't take too long on this, but this is what I'm doing the research on right now, trying to figure out how does this apply? What is the significance of the Arctic oscillation in February? But also, I'm working on other things like models, trying to mobilize this research and apply it to other teleconnections to figure out what is the true significance, what drives what. So, without further ado, I'll go into this data set, and I hope you can see this. Make sure you get your high resolution on for your video watching machine, YouTube. There. So basically, the way I broke out the classic view. So let's start in the upper left. Classic view. This is where things typically tend to be viewed. So you're looking at like a positive versus a neutral versus a negative AO. In this situation, I limited the results to the top 10 positive AOs and the bottom 10 negative AOs. So you're getting the most extreme positive side of the spectrum and the most extreme negative. And then you're getting a group subset right there in the middle. So when we do that, what does that mean for temperature, snow, precipitation, that kind of thing? And that's what this shows. Okay, so for example, for Green Bay too, by the way. Now the reason we picked Green Bay is because Green Bay's record is very long and very consistent, and it doesn't seem to have the issues with urbanization, with heat island kind of things, because there's not as much built up around it. So if you look at the Milwaukee site, that one's a Frankenstein site right there. Anyways, temperature here, you're seeing the negative AOs tend to be colder for Green Bay. So that's a 26 versus a 28 average, okay? Versus a positive AO, which is kind of near the average, which I thought was interesting. And then the neutral is even more interesting. Why is that positive, okay? So it's not like, positive AO, it means it's going to be blow towards warmth. Negative AO doesn't necessarily mean, probably colder, yes. But so it's interesting there. That spectrum is interesting. The snow was really surprising to me how big of a significant difference that was. A negative AO. So you're thinking with a negative AO, you're thinking more amplification of the pattern, probably more cold air in the United States. That tends to produce less snow for Green Bay. Isn't that amazing? So that's a 6 inches versus the 9-inch average, 10-inch average. Whereas a positive AO will bring more than average snow. So it's 13.5 versus 10. That's an interesting relationship. The precipitation, that's also interesting. So look at that. The average is closer to 1.4, which I think what you're seeing there are like big lump sum months sometimes where it rains. This is an average. So 1.5-inch average might end up being on some months, the top months, 3 inches or something like that. So you might see that kind of distorted, biased upwards versus an AO that's negative and you're only seeing 0.9 inches. And I think that kind of makes sense if there's more cold air in the United States. The other thing that's interesting is maxed 2-day snowfalls. I know this is cut off in here, but you're seeing, I don't think that average is correct, but these values are correct. That the 2.6 versus the 6.6, so 6.6 in a positive AO, most extreme cases, and then the neutral is sort of in the middle. The days with snow, That is that middle to last column there, that one in from the left. It's interesting to note that there's really no relationship there in the classic view, but there is a relationship in a new view I created. We'll get to that in a second. And then the temperature ranges, pretty big difference. So again, like I said, it looks like there's more cold air, a range. Sorry, this is the range of temperatures. I apologize for that. That 48. So there's a smaller range in temperatures and a bigger range near neutral and positive. Oops, sorry a second. Grab something. Okay, we're going back to that temperature itself. It looks like, yeah, so that's kind of a key thing. But yeah, so what I wanted to do was to kind of get a measure of variability. So right, when we go back to the AO, you're seeing that it's mostly positive, but within there, you're seeing an up and a down, an up and a down. How variable, basically if it's a highly variable pattern, but it reads out as like a positive 2 AO, what does that mean versus a low variability, just a consistent flat positive AO? Is there any sort of tendencies that way? So that's what this final group over here tends to show. And actually, it shows a lot of the same trends, but I think the classic view is a lot stronger with its what it shows. The one area that actually was very interesting in the discovery that I found was the days with snow increases by about 2 days in a highly variable, like a top 10 variable AO pattern. This is highly variable, does not mean positive AO, does not mean negative AO. It just means variability within that, and at any case. And so that's interesting. So this is sort of like a variability or a volatility index a little bit. So I thought that was interesting. But yeah, basically, it looks like the classic positive versus neutral versus negative AO is a good analysis for most things. But when variability is high, the days with snow increases by 2, as I mentioned. And in that last point I mentioned also. Okay, sorry, one more thing. And this is sort of what it led into. I guess I wanted to double check things. Again, there's that data. This data point here is wrong. But basically, I just want to look at positive versus negative. So if you took the entire data set, so it goes back to 1950. If you took all those years and cut them right at 0, so you have 25 that are a positive AO all the way up to 1990, 1989 values, and then you take from that 0 down all the way down to the coldest, or not the coldest, but the most negative examples. What are those? So it's like 2 teams, right? So negative versus positive. What do you find? Well, you find that the results are a lot more watered down. And you're not seeing as strong of a signal or clear of a signal. So that's all this is kind of showing here at the top half of this. The bottom half is a little different, but the top half is basically saying, yeah, you have to kind of look at the extreme cases to get the best, most clear view of things. So that was kind of encouraging to my research here. Now, this next section here, we're starting at the variability versus snow. I think this is really what I was trying. It's not labeled correctly, but positive AO versus negative AO. So on the left is positive, on the right is negative. In the middle, you would probably find the neutral in between cases. And then on the left side here, on the y-axis, you have the average of snow. But I'm comparing. That would be. Sorry, I'm just trying to remember the variability. So on the y-axis is the variability. So top 10 variabilities and top 10 positive AOs tend to yield the heaviest snows for Green Bay. So that, for example, top 10 for both equals about a 28.4 tendency there. And then, again, the one thing to remember is we're only looking at about 70 years of data only. But some of these sample sizes are not very big because you're not necessarily going to have a whole lot of top 10s. But my point of this, and I was just doing it because I was curious, but it generally seems that that the snowiest Februarys are highly variable, positive Arctic oscillation situations. Not always, but tends to be. The least snowiest tend to be highly variable, negative AOs. So that's really interesting. So it's not a measure of variability. It seems like the more variable it is, it has different end results, I guess. So again, sample size is not very big. So that was interesting. So So that led me to this, and this might not be helpful. I mean, maybe you don't like the walls of numbers, but maybe the map will help to kind of explain a little bit. This is an example of those top 10 positive AOs, what that looked like in February for the Northern Hemisphere. And I apologize if this is really small, but you're seeing generally the difference between the positive height anomalies at 500 millibar and negative. That angle or that relationship is kind of flatter. It's more zonal. I'm not saying it is zonal. I'm saying it's more zonal, maybe more longitudinal, versus a negative AO, which is actually in the opposite relationship. But you're seeing the cold negative height anomalies spreading down across the northern hemisphere. So going back to the positive, you're seeing that polar vortex is bottled up here, and then in the negative, on the complete opposite end of the spectrum, you're seeing that it's the cold air, the negative height anomalies are working south. So it's sort of like if you look at the upper hemisphere and you watch it as it rotates around, the Arctic oscillations, Arctic polar vortex as it rotates around, as it mixes south, you reach a point at maximum mixing, and that seems to be a negative, that negative AO, those top 10 negative AOs. So when you're at that maximum in either case, that's what it looks like from a height anomaly perspective. What I thought was interesting was the neutral AO, because that was the one that seems to be kind of driven by something else. It doesn't seem to be, it was kind of weird to me. Look at how, and this is the smaller one here, but basically what it's showing is this negative height anomaly, like showing the strong polar vortex, looks to kind of slide over into the western United States, I would say western North America, and that height anomaly kind of gets dislocated, and then the angle between the positive and the negative height anomalies becomes more poleward. Okay, so now you're inducing more amplification of the pattern. So it seems like somewhere in between there you have an amplified pattern, more amplified pattern, and then the endpoints are just totally different ends of the spectrum. So I think you can still get a lot of good storms in that neutral phase, but I think it's just really interesting. So we're going to keep going into it. Another thing that I'm working on is this. This is totally unrelated. This is the April 10th, outbreak for Wisconsin. I'm trying to do a project on that. We'll see if I get to it this week. It's going to take a while. Probably more likely next week. Okay. So let's go into the pattern. And I know there's a lot there. I apologize if it's kind of hard to read or hard to see or hard to understand what I'm saying, but what I'm trying to point out is it's pretty dang complicated. And I guess my goal is to find a way to predict winter, temperature trends, and it looks like you can do it with an AO. You can say that, generally a positive AO might yield more than 3 inches above the average. So you could say, yeah, it's probably going to be more snowier in February if you know that it's going to be a positive AO. But how do you know that it's going to be a positive AO? So I'm going to go back to this because this is really telling to me. Sorry, I can't let this go. I got to go back into it. Why won't it go? Oh, because I'm pressing the wrong button. Go back to this, right? Look at all those differences. So let's just look at February. See, some years it's positive, some years it's neutral, some years it's negative, very negative, like 2010, and negative 4.1 in February. But there's no guarantees. It's sort of just like a, whatever. So when we're sitting here on the 10th month of the year, being October, going, okay, how much snow are we going to get this year? Well, what's the AO going to be? Well, it could be anything, So you rely on the operational operational models that, CFS for one, monthlies, the seasonal models, which is different from statistical analysis. And I just don't have much faith in that. It just seems like it's based on this initial set of conditions, and whatever happens is, by the time you get to 3 months down the road, who knows? But I think there might be a way to back into it with looking at sort of these relationships. So it kind of starts with understanding what's the most significant teleconnection. El Nino, La Nina. So ONI, that might be the top one. Maybe not. Sunspot data. So that has definitely got an impact. And I could show you that too. I don't have the data ready, but that has an impact. So what's driving what, And then AO, what tends to happen in any of those sunspot situations? Negative. So if you're at a sunspot minimum versus a maximum, what are the different tendencies there? And so then you might be able to back into what will happen over the winter year. So that's things I'm thinking about. But anyways, yeah, I mean, look at, and then another thing that I thought was interesting is if you look at February and March from 1990, and then if you look at the years following it, that 1991 was colder. Not in case I have it labeled as a colder temperature. That's why I say colder, but it's a negative AO during the year following that positive, strongly positive. So it's like it could flip completely. But you also see an interesting trend going back in the winter for the next few winters. So you're seeing a 2.9 there in March 1990, and then you're seeing maybe like a 1.1 there in 92 in February, and then in January of 93, then you get your peak, and then in November of 1995, you get a peak, and then it's done, and then like everything resets. So that's really interesting. So the things I'm working on. Anyways, we're done with that. Let's go into the GFS operational model. And maybe what I'll do is I'll break this video into two parts. And this second part will be basically what I'm looking at for the next week or two. And I'm using weather.cod.edu. I just prefer it. This is the latest 12Z GFS model. Looks like it's fully initialized. So this is picking up on Friday. Maybe some light snow there across the Great Lakes region. But then you see that surge of warm air coming into the weekend. You got looks like a low pressure system more on the polar side of things, pulling things north, not fully phased in. And then as you go into early next week, you see that low moves off through southern parts of Canada. And then you have another bundle of energy down here in the southwestern United States. So it's not fully together, not in phase. But as we go into, let's see, so this is March. This is Monday, Tuesday. You're seeing that a low pressure system does kick out, but I think the models have been backtracking on this. Initially, they looked very strong for this system. I mean, initially by that, I mean like 5 days ago, I was like, this looks like a major storm there in that next week time frame. But it's backed off, and it kind of reminds me of the last storm. But anyways, that kicks through. And then it's sort of like a null thing. So it looks like that storm for next week is probably not going to happen. And I guess we could probably relate that back to various positions of the MJO and the AO. But yeah, so that, and then you get into March 7th. So this is next week, and not this, but next. So March 7th, then it throws another storm system up. So basically what we're heading towards is that, the phases 5, 6, and 7. You're looking now here by mid-March trying to find symptoms of that. And I see maybe there's a storm there. And then as you keep going through it, so March 10th, March 12th, you're seeing a major storm blow up across the eastern United States. But at 327 hours, that could be anywhere across the United States. So, or may not happen at all, So I guess that's why we go back to these MJO methods and we go to, AO teleconnections, is because that helps you on the 2 to 3 plus week range in the monthly scale. These operational models, when you try to take them out to a weekly, monthly scale, it doesn't work out, and you're knee-jerking constantly. I know that I've kind of been reading some comments on the CPC forecast, and those things have been changing wildly back and forth. So, I mean, as a good goal to not be so knee-jerky with your stuff and try to be more consistent. I guess consistency, you don't want to be in denial or ignoration of the current trends, but you kind of just want to smooth out the peaks and the valleys. And that's my goal. I don't know if it's possible, but we'll see. But this is the CPC forecast for the 6 to 10 day time frame. I think that's interesting that they do the positive anomalies there. I mean, it could be, it could be that way. But based on the MJO, for heading towards 4, yeah, perhaps. But by the time we get to 5, I would expect to see colder temperatures working into northern United States. The precipitation trend is a positive here over the eastern United States. Now, that's a 6 to 10 day. We could take a look at the 8 to 14. I mean, I don't know. I don't know. I don't like the way these look right now. I don't know. I don't know if I agree. We'll go back to Outlook Maps, and then we'll go to a monthly. And this is where I thought was interesting. That was for February. We want to look at March if they have it. I know they have it. Monthly. I just clicked on that. Let's go to home, because maybe that's where it'll be located. 1 month temperature outlook. So yes, this would be March. So if you look at temperature, here, come on. Okay. Yeah, so I mean, they have a below average here in the north. I don't know. Maybe February 20th. I don't know. They to me, I don't know. I don't feel like they have a good handle on this situation. I just don't see that below average trend working out for them based on the current position of the MJO. So, okay, guys, that's what I got. I'm gonna write this story up, and then I'm gonna put it on the website so you can go check it out there. But most of the stuff is gonna be contained within the video. Thanks for watching. I'm gonna try to do more of this and hopefully get it a little bit more um, sorted out. I guess I can't find the words. I'm losing my words here at the end of this. But thank you for watching. I will talk to you soon.